Hi, welcome to our group project. Our topic is analyzing car price data using non-parametric methods. First thing first, we need to dive in our research problem. This study used non-parametric statistical methods to analyze how different car features affect pricing and market combinations without making strict assumptions about the data's distribution. Specifically, it investigates three main problems. One, whether having a leather interior creates a significant difference in a car's median price. Second, whether different categories represent distinct pricing groups. And the third one is whether a car's fuel type is statistically related to its gearbox type. Ultimately, this research aims to understand the factors that influence car pricing that typically exhibits highly skewed distributions, heavy tails, and extreme outliers.
Hello everyone, next I will present the objective of our studies. Our study has three main objectives. The first objective is to determine whether there is significant difference in car price between vehicle with and without leather interiors. The second objective is to determine whether there is significant difference in car types among different car categories. The third objective is to examine the relationship between fuel type and gearbox type of cars. And then to achieve this objective, we selected appropriate non-parametric statistical tests based on type of variable and research questions.
In this study, we use and obtain secondary data from Kaggle website. That dataset is called car price prediction. This dataset was selected because it contains information about vehicle characteristics that are relevant to our research objective. Before the data cleaning process, the dataset contained 13 variables and 19,237 observations. After removing missing values and irrelevant variables, the final dataset consists of 6 variables and 10,237 observations. These variables were retained because they are directly related to our research objective. Now, let me briefly a little to describe for each variable. The first variable is ID. It is the unique identifier assigned to each car and it is not used in the statistical analysis. Second, the price variable is a numerical variable that represents the selling price of a car. Third variable, the leader interior variable, is a categorical variable with two categories, yes and no, indicating whether a car has a leader interior or not. Number 4, the category variable is also categorical and describes the types of vehicle such as sedan, hatchback, and coupe. Number 5, the fuel type variable is categorical with categories including petrol, hybrid, and diesel, representing the type of fuel used by the car. And lastly, the gearbox type variable is another categorical variable consisting of automatic, manual, and Tiptronic transmission system. In conclusion, the clean dataset contains only the relevant variables needed for our analysis, make it suitable for achieving the objective of this study.
For the first objective, we use Mann-Whitney U test. This non-parametric test is suitable because it compares the median car price between two independent groups, which are vehicle with leather interior and vehicle without leather interior. The null hypothesis states that there is no significance between median car price and two independent groups, while the alternative hypothesis states that there is a significance between median car price, and two independent groups. For test statistic, we use Mann-Whitney U test formula, and also we calculate it using SPSS. For decisions, we make based on p-value. If the p-value is less than 0.05, so we reject the null hypothesis. Otherwise, we fail to reject it.
Next, I will explain the methodology that used in this study, which is the Kruskal-Wallis test. The purpose of the Kruskal-Wallis test is to compare the median values among more than two independent groups. This non-parametric test is suitable when the data does not satisfy the assumptions. For the hypothesis, the null hypothesis H null states that the population distribution functions are identical, meaning that there is no significant difference among the groups, while the alternative hypothesis H1 states that not all groups have the same median, indicating that at least one group differs significantly from the others. For the test statistic, Kruskal-Wallis test is represented by H. As shown in the formula, the statistic is calculated based on the ranks of the observations instead of the original data values, make it more robust for non-normally distributed data. Finally, the decision rule is straightforward. We reject the null hypothesis if the calculated H value is greater than the critical value from the chi-square table, or equivalently, if the p-value is less than the chosen significant level, which is commonly 0.05. Otherwise, we fail to reject null hypothesis. To sum up, the Kruskal-Wallis test helps determine whether there is a statistically significant difference in the median values across three or more independent groups.
Our third methodology is about the chi-square test of independence. The purpose of this test is to analyze relationship between two categorical variables. The null hypothesis for this test is factor A is not related, have no relationship, or have no association to factor B, while the alternative hypothesis is factor A depends, have relationship, have associations on factor B. The test statistic that we use in this test is the chi-square. We can calculate the test statistic using the formula given, which is the sum of Oj minus Eij squared over Eij. The Oj is the observed frequency that we get from this data, and the expected frequency can be calculated using the formula given too, which is we the column total multiply it with the row total over the sample size. The decision rule is we reject H null if chi-square calculated is greater than chi-square alpha with degrees of freedom.
This slide shows that the result of Mann-Whitney U test for our first objective. The null hypothesis states that there is no significant difference in car price between vehicle with and without ladder interval, while the alternative hypothesis states there is significant difference. Based on the SPSS output, the p-value is 0.258, which is greater than level significance of 0.05. So we fail to reject H null. Therefore, we can conclude that there is no significant difference between car price between vehicle with and without ladder interval. This suggests that the ladder interval does not significantly influence the car price in our dataset.
Next, look at the result for second objective by using Kruskal-Wallis test. The null hypothesis states that there is no significant difference in car price among the different car categories, while the alternative hypothesis states that there is significant difference in car price among the different car categories. Look at the test statistic. The output from SPSS was produced a chi-square statistic of 124.218 with 2 degrees of freedom and p-value less than 0.0001. Since the p-value is less than the significant level of 0.05, so we decide to reject the null hypothesis. Therefore, we conclude that there is a significant difference in car price among the different car categories, indicating that the median car price differ across the categories.
The result of the chi-square test of independence. The hypothesis for this test is there is no significant relationship between a car's fuel type and its gearbox type. And the alternative hypothesis is there is a significant relationship between a car's fuel type and its gearbox type. The test statistic that we can calculate from SPSS is the p-value, which that we get is the p-value is less than 0.0001. The decision rule is reject H null if p-value is less than alpha, which we can conclude that since p-value is less than 0.01, which is less than alpha 0.05, we can reject H null. So the conclusion is there is a significant relationship between a car's fuel type and its gearbox type.
To summarize our study, we successfully achieved all the three objectives. For objective 1, the Mann-Whitney U test shows that there is no significant difference in car price between vehicle with and without leather interiors, with the p-value of 0.258. For objective 2, Crooker-Wallace test indicates there is significant difference in car price among different car categories, with the p-value is less than 0.0001. For objective 3, the chi-square of independence shows that there is significant positive relationship between fuel types and gearbox type, with the p-value is less than 0.0001. Overall, there is significant difference with car categories and positive relationship between fuel types and gearbox type, while the leather interior does not affect the car price in our dataset.
The overall conclusion from this study is that we successfully applied non-parametric statistical methods, which are the Mann-Whitney U test, the Kruskal-Wallis test, and the chi-square test of independence. We also identified the true structural and mechanical driver of vehicle values versus minor cosmetic additions. Overall, this study indicates that a vehicle's macro level classification and core mechanics are the true drivers of market trends rather than minor luxury add-ons such as the leather interior. So that's all from us. Thank you. Bye.